Welcome folks to my maths channel. I'm doing this question today, which was a request from Dwayne Jr. the Fourth from Jamaica. Now Dwayne, I hope that there will be similarities between South African mathematics and Jamaican mathematics. Anyway, mathematics is a universal language, my man. Now, folks, we are dealing with functions here. Now, we normally refer to functions as f of, g of, h of. In this case, we are given f of x, which is equal to 2x squared minus 9x plus 10, which is defining a parabola. Now, it says to us, by completing a square, very clear, by completing a square in f of x in this one, show that f of x can be expressed as a into x minus p, close bracket, all squared plus q. Now, completion of the square, we do this in grade 11 in South Africa. I don't know in Jamaica, you normally refer to class 11 and class 10, but we do this in grade 11. Completion of the square has got rules. I think it's about 4 rules. Now, let's put the equation there for number 1.1, which was number A. According to Dwayne, it was written as x is equals to 2x squared minus 9x plus 10. But now, as I said, in my country, we use that f to show that it is a function. Now, completion of a square requires certain steps. Step number 1, you need to make sure that the numerical coefficient of x squared, the number in front of x squared, is 1. That is step number 1. Step number 2, after you have made this one, you therefore take the numerical coefficient of x, you multiply it by half, you square it, you edit both sides of the equation. If you are dealing with an equation, in this case, we are dealing with an expression. Now, dealing with an expression, it would mean you add the numerical coefficient and subtract it at the same time. Now, let's go through step number 1. Folks, f of x, I said the numerical coefficient of x squared must be 1. If it was an equation, I was going to divide throughout by 2. But now in this case, because it is an expression, I must remove 2 as a common factor. Now, taking out 2 as a common factor to me is the same as dividing each one of them by positive 2. In this case, when I divide this one by positive 2, I would get x squared. When I divide this one by positive 2, I would get 9 divided by 2x. When I divide that one by positive 2, I would get a plus 5. Now, the numerical coefficient of x squared is now 1. That means I can go to step number 3 now. What is step number 3? Remember, I said when the numerical coefficient of this is 1, you therefore take the numerical coefficient of x, you multiply it by half. Some people normally say you divide it by 2, that's fine. You multiply it by half because we have an expression. You add it and subtract it. That is the same as doing absolutely nothing. You haven't changed anything. Now, I'm going to do that. There we go. X squared, that one, minus 9 divided by 2x. Now, I'm taking the numerical coefficient of x plus, open bracket, 1 divided by 2 multiplied by minus 9 divided by 2. I square that. Now remember, it is an expression. You must add and subtract it. That is 1 over 2 multiplied by negative 9 divided by 2 all squared. Then we add that 5, which was always there. Now, what are we doing here? Completing a square. We are making this expression a perfect square. That is what we mean by completion of the square. That would be 2. Let's have a square bracket there because I have other brackets now there. That is x squared minus 9 divided by 2x. That is a plus. I multiply this by that, I get negative 9. I square it, I get positive 81. I multiply this by that, I get 4. I square it, I get a beautiful 16. That means that this bracket, because it's the same as that, it would give us the same answer, but negative 81 divided by 16 plus a 5. Square bracket there. Folks, I hope that you follow this. We made the numerical coefficient of x squared 1 by removing the common factor. Then in this particular step, because it is an expression, we took the numerical coefficient of x, we multiplied it by half, we squared it, we added it both sides. Remember, it was going to be plus this side, it becomes minus. All right, folks, let's continue. That now gives us 2 into x squared minus 9 divided by 2x plus 81 divided by 16. What I want to say to you now is, you have made this a perfect square. Then, what am I going to do there? I'm going to add these two together, but now I keep this as it is. It would be minus 81 divided by 16 plus 5. Let's close that there, which is equals to, now from here, folks, from here, I'm going to factorize this. Remember, I said completing a square. You are making this a perfect square. Let's factorize it. That is 2 into, I keep this bracket. The factors of this would be x and x. The factors of 81 divided by 16 would be 9 divided by a 4 there. Then because we want to add, it would be a minus. Then it's a all squared there. Remember now, we made this a perfect square. Now, let's go to this side. It would be a minus. Let me have the LCM there. My LCM is 16. Now, 16 divided by 16 is a 1. 1 multiplied by minus 81 is a minus 81. 16 divided by 1 is a 16. Now I have got 16 multiplied by 5. Let's do it there. 16 multiplied by 5. 6 fives gives us 30. Let's put a 3 there. Then 5 ones are 5 plus that. It's an 80. Remember, we still have got that 81 there. It's a plus 80. Then this is going to give us minus 81 plus 80, which is a negative 1. Let's remove that. Beautiful. Now, what am I going to do now? I'm going to remove this bracket by multiplying throughout by a 2. That would give us now f of x, which is equals to 2 times this bracket is 2x minus 9 divided by a 4 all squared. I multiply 2 by negative 1 divided by 16. That would give us negative 1 divided by 8. We have completed a square, and we have written this expression or equation in a form a into x minus p all squared plus a q. Now, what is the next question? Our next question here was, what is the range of f of x? I'm going to answer that. Before I answer that, I want to explain the word range. The word range in your function means all the y values of your function. That means if the function has got minimum y value and it is concave up, it means from minimum to maximum. If it is concave down, it would have maximum value at the turning point, and going to minimum, it would mean from minimum to maximum, all the values of y. Let's look at this function. This one is concave up. Now, meaning that we will have the smallest value of y there and the biggest value of y somewhere up there. Now, let's go to this equation. Remember that this tells you the x value of the turning point, and this is the y value of the turning point. That means that now this one is the value of y of that particular point. I would say at this point, my x value is 9 divided by 4, and my y value would be minus 1 divided by 8. Can I remind you of something, my friends? When this is negative here, it becomes positive as the x value of the turning point. But now this one takes its sign from here to there. Please keep that in mind. Now, I am giving the range of f. The range of f would be greater or equals to, okay, let's write it in this beautiful way, because now I'm talking to my Jamaican friend. I want to write it in an international way. It means the value of y would be greater and equals to, because this value is also equals to that, minus 1 divided by 8. I hope that everyone gets this. Your range are all the values of y. What are our values of y? Our values of y in this particular one have got a minimum value there and the maximum value there. That is why I'm saying the y values would be greater and also equals to minus 1 over 8. It means from here we have minus 1 over 8 and all the other values of y in this particular one. Beautiful question. Number 1.3. 1.3 says, what is the domain of this particular function? Remember, for you doing now, it was that. What is the domain of that? Now, let me explain the domain. The domain of this function are all the values of x that can be substituted there or there without giving us any problems. Problems, I mean making this undefined or any other thing which is not mathematically acceptable. Now, you look at this one. If you can take any real number and substitute it here, I bet you will never have any problem. I repeat again, you take any value of x which is a real number, you will never get a problem if you substitute it there. Okay, folks? Beautiful question again. Now, let's get to the next one. Next one. I want to talk to my friend again, Dwayne in Jamaica. Your question was, complete a square here and find all the intercepts with the axes. Now we have completed the square there. Now I'm going to find all the intercepts with the axes. What I know is that for the y-intercept, x must be equals to 0. Now, I'm looking for the y-intercept where this graph is cutting the y-axis. The value of x must be equals to 0. Sorry, folks. I 0 x there. When I do that, it becomes 0 minus 9 divided by 4, which is minus 9 divided by 4, all squared. Now, what happens? I square minus 9 divided by 4. When I do that, it is going to give us 2 multiplied by 81 divided by 16. I multiply these two. 2 goes once there, it goes 8 times there. Then from there, I take 81 divided by 8, which I got from here. I therefore add it to 1 divided by 8, which is going to give us, sorry folks, remember it is the y-intercept. The value of x is 0. Now, which is 0 is to 10. I just want to have something to drink now. Oil. The problem is making me cough. All right, there it's a comma. Beautiful. Now, this is our y-intercept. I'm now looking for the x-intercept. For x-intercept, the value of y now is equals to 0. That means here, I must make this 0 and solve this particular equation. Let's do that. it would be 2 into x minus 9 divided by 4 all squared minus 1 divided by 8 is equals to 0. Let's take this to that side. It is 2 into x minus 9 divided by 4 all squared, which is 1 divided by 8. Beautiful. Now, I'm going to divide both sides by 2, which is the same as multiplying by half. Now, that would give us x minus 9 divided by 4 all squared, which is, I divide this by 2, 1 divided by 16. Then, because it's a perfect square, I'm going to take the square root of both sides. Let's do that. Let's do it in red here. Square root of that side and the square root of that. Remember now, this must be plus or minus. Then this would give us x minus 9 divided by 4, which is equals to, I take the positive 1 divided by 4, or x minus 9 divided by 4, which is equals to, we take the negative answer, 1 divided by 4. Beautiful. Now, let's take this to that side. It would give us x, which is equals to 9 divided by 4 to that side is going to be positive. We add it to that, it gives us 10 divided by 4, or x is equals to, we take it to that side, it becomes positive, we subtract, becomes 8 divided by 4. Now, I can hear Dwayne saying, please simplify those fractions. Say, I'm going to do that, Dwayne. I'm simplifying them. It is not only you, everyone is saying that. That would be 5 divided by 2, or x is equals to 2. Now, I have the y-intercept, x-intercept. Beautiful. Now, from this, I'm going to try and draw my graph. I'm actually not trying, I'm drawing that beautiful graph. Let's have it. Our Cartesian plane. There we go. Now, how many points are we having? We have the y-intercept, x-intercept, turning point. I'm now sketching it, Dwayne, and everyone. The y-intercept is 0 to 10. Then, one of the x-intercepts is 2 to 0. It would be here. 5 divided by 2, that is 2 halves. It would be somewhere here. Let's put it here. Now, let's go to the turning point. 9 divided by 4 and positive. It would be somewhere here. The axis of symmetry, I'm drawing it as a dotted line. That is x is equals to 9 divided by 4. I'm sorry about that. Then we've got negative 1 divided by 8, which would be fair there. Now, that point is there. Our graph is concave up. I'm drawing it there. That's our graph. We have shown y-intercept, x-intercept, turning point. Dwayne, it was a beautiful problem. It woke me up from my flu bed. That is why I'm coughing a bit constantly. So I hope that you follow this, my brother. Your last question was, verify these 2 points using the quadratic formula. Now, quadratic formula, you will do that, Dwayne, but you will still get exactly the 2 values of x. I'm signing off, Dwayne, running to my bed again as I was sleeping because of flu. Folks, I hope that you understood completion of the square. I hope that you understood what the range is. I hope that you understood what the domain is and why specifically we picked this one. I hope that you understood how to determine the intercepts with the axis. Now you look at our graph. The smallest value of y is there, and the biggest value is right up there. Folks, all the best.